Are you ready for another awesome lesson? I hope so. And I hope you think they're awesome. I wish I could be in the classroom with you and have you guys around me and talking to me. But right now we have to do it this way. I sure miss you, and I sure hope that you like the lessons as much as you can when we have to talk through a computer screen. All right, guys, we're going to start with our review of last week. So if you don't have a paper and pencil, run and grab one, pause the video, run and grab one really quick, and then we're going to start with our review. All right, let me get our review up here. Okay, here's our review. Sorry, sometimes it takes me a minute to track them down. Okay, lesson 25, week 25 lesson review. So put on your thinking caps, turn them way up. What did we learn about last week? Question number 1. Who did we learn about last week? If you think we learned about Queen Victoria, write the letter A. If you think we learned about Queen Elsa, write the letter B. And if you think we learned about Queen Elizabeth, write the letter C. All right. I hope you wrote the letter C. We learned about Queen Elizabeth I. Good job, guys. Let's move on to question 2. Who was Queen Elizabeth the daughter of? So who was her dad? If you think her dad was King Henry VIII, write the letter A. If you think her dad was King Louis, write the letter B. And if you think her dad was King George, write the letter C. Are you ready for the answer? A, King Henry VIII. Good job, guys. Let's move on to the next one. Number 3. What did Queen Elizabeth never do? There was something that she never did. Do you remember what it was? If you think it was win a war, write the letter A. If you think Queen Elizabeth never won a war, that would be letter A. If you think she never got married, write the letter B. And if you think she never won the love of her people, write the letter C. All right, here comes the answer. B, Queen Elizabeth never got married. Good job, guys. Let's move on to the next one. Number 4. What is one of the reasons Queen Elizabeth might not have wanted to marry? So we don't really know for sure why she didn't get married, but people have some ideas. What do you think those ideas are? Why do you think she chose not to get married? She had a lot of people that wanted to marry her, but she never said yes. Do you think it's because she would lose a lot of her power to her new king? That would be A. Do you think she was too scared? That's letter B. Do you think she got too old to get married? That would be the letter C. Why do you think she chose not to get married? Okay, here's the answer. The answer is letter A. She would lose a lot of her power to her new king. So back then, kings were more powerful than queens. As long as she was the only ruler, she had all the power. But if she married, then that power would go to the king, and it wouldn't be hers anymore. So one of the reasons people think she chose not to marry was because she didn't want to lose her power to the king. Okay, true or false? You're not going to write an A, B, or C. You're going to write a T for true or an F for false. Listen to my question or my statement and write a T for true or an F if it's false. Queen Elizabeth would ride through her towns and villages so her people could see her. Do you think she would ride through her towns and villages? If you think she did, write the letter T. If you think she didn't, write the letter F. True. Queen Elizabeth would get on her horse and ride through her towns and villages so her people could see her. This is probably one of the reasons that her people loved her so much. All right, question 6. Here we have a picture of the Globe Theater. The stage of the Globe Theater had 3 levels. A top, right here, a top level with a trap door. Remember, there was a trap door right here. And then there was the main stage. This is where all the actors would be performing their play. And then there was a trap door that went below the stage. What did these 3 levels represent? If you think they represented rich people, middle class people, and poor people, write the letter A. If you think they represented earth, fire, and water, write the letter B. And if you think it represented heaven, earth, and hell, write the letter C. Good job. Let's find out the answer. Did you write C? I bet you did. So the top trap door up at the very top of the Globe Theater, that represented heaven. Whenever they had a play that had an angel or somebody from heaven, they would come through that trap door at the very top of the theater. The middle part of the theater represented earth. It was just the land that we're all on. And then when somebody would die or when there was a bad character, the bottom, the trap door that went below the stage, that would represent hell. Good job, you guys. Let's move on. Queen Elizabeth loved fashion. What do we call this style of fashion? If you think we call it modern style, write the letter A. If you think we call it Elizabethan era fashion, write the letter B. And if you think we call it vintage style fashion, write the letter C. Are you ready for the answer? The answer is B, Elizabethan style. It was actually named after Elizabeth. Elizabeth Elizabethan. So this was her fashion and it was named representing her. Take a look at this dress over here, guys. Look what's around it. Do you see the Tudor ruff around the neck? You think that would be super scratchy? I think it would be, but look how gorgeous that dress is. Way to go, guys. You did amazing. I'm so super proud of you. That's the end of our review. However, I did have another knock knock joke come into me this week. So we're going to take a look at our knock knock joke. That is an awesome knock knock joke. Thank you for sharing it with us. Thank you for that knock knock joke. If you guys want to send some more in, I would love to include them in our lessons. I'm still waiting for, I've got a few pictures of our fashion show. Not a whole lot yet, so I'm going to wait till next week before we put those in. So guys, I have a question for you. So I have this globe here. It's also a ball, right? Okay, you all know that our world is spinning, right? Our world is turning. Turns around, turns around. So here's my question. If we are turning around right now, why can I not feel it? Everybody sit really still for a minute. Can you feel the world moving? I can't feel it moving. But when I throw this ball in the air, if our world is moving, our ball should come down somewhere else, right? All right, let's test it out. It didn't, it came down in my hands. Let's see. Oh, well, it does move if it hits your head. Guys, if our world is moving, why is the ball still coming straight down to me? Why is it not landing way over there? Because the earth is spinning really fast. Well, we're going to learn today about a guy that had that same question and some of the amazing things that he did. Before we get into that, I want to show you another picture. We're going to bring up our knock knock joke here for just a second. All right, take a look at this picture. What's wrong with it? Look really, really close. What is wrong with this picture? I'm not going to tell you yet. We're going to come back to that pretty soon. Okay, I'm going to show you a video about this amazing scientist. He loves space. If you look behind me, we're in space today. So cool. But I'm going to show you this video about this guy that loves space. He's going to tell you 2 words. I want you to really listen to what those words mean, and I want you to try to remember them for next week. I'll pause the video during those words to tell you about them, but I want you to really try to lock those in your brain, right? So let's bring that up. Here it comes. Uh-oh, what has happened? Hang on a sec, guys, I gotta figure out what's going on. Okay, some technical difficulties. Hang on a second. I don't think I had the sound turned on for that video, so let's try this again. Let's make sure we have the sound on.
The Earth orbits
All right, and let's start it over. Here we go.
Hey, check it out, Europa. Hey. Dear Tim and Moby, if the Earth orbits the Sun, how come we can't feel it moving? Thanks, Hans.
Hey guys, Hans had the same question I had. How come we can't feel the Earth moving? We're sitting on it, right? I can't feel it moving. If I throw the ball in the air, it comes down in the same spot. That's really strange. Are we sure that the Earth is moving? Let's see what Tim and Moby have to tell us about that.
Great question, Hans. Even the brilliant minds of ancient Greece had a tough time with this one. They saw the sun rise and set every day. At night, the stars moved across the sky. And like us, they couldn't feel the planet moving. All of these observations supported a geocentric model. That's the idea that Earth stands motionless in the center of the universe.
Okay, that's the first word I want you to remember. Geocentric. That means the Earth is right in the middle and it's holding still, and everything else is moving around it. Way a long time ago, back in the Renaissance times, that's what they believed. Geocentric. You guys remember that word?
And that everything else revolves around us. The Greek philosopher Aristotle based his whole system of astronomy on this idea. He saw the universe as a set of transparent shells. Each object in the sky was attached to one of these celestial spheres. Beyond them lay the sphere of the prime mover. It was the engine of the system, triggering the motion of the sun, moon, and planets. Laugh all you want, but Aristotle's system had its uses. It could predict the positions of planets and stars in the sky, roughly. So people stuck with it, despite a few inaccuracies. Aristotle's model didn't explain why some planets looked brighter at different times of the year, or why some planets seemed to reverse direction. A Roman astronomer named Ptolemy figured out the model was just incomplete. In his view, planets weren't directly attached to celestial spheres. They rotated around them in perfect circles he called epicycles. As they moved along their epicycle, planets would appear brighter when closer to Earth. This also explained why planets might seem to hover in position or move backwards. Ptolemy added more and more epicycles to fill in all of Aristotle's blanks. The Ptolemaic model was complicated, but also incredibly accurate. It predicted the exact position of every observable object in the night sky, so it continued to be used for more than 1,000 years. Many astronomers after Ptolemy were clerics, scholars in the Catholic Church. The Church approved of the geocentric model because it fits so well with Christian thought. The prime mover was obviously God, and humans were his central focus, positioned smack in the middle of all the action. But a Polish cleric named Nicholas Copernicus started to notice some problems. He didn't totally reject the geocentric model. Copernicus just thought it needed some adjustments. To his surprise, he found many alternatives to geocentrism dating back to the Greeks. Reading these ideas helped him develop an entirely new vision. What if the rising and setting of the sun was not related to its motion, but the spinning of our own planet? And what if all the planets, including Earth, revolved around the sun? Anytime Earth passed another planet, it would look like that planet was reversing direction. For the next 15 years, Copernicus worked out his heliocentric model. He added the suggestion that the Earth was tilted. That would explain the yearly cycle of the seasons.
Okay, guys, the second word I want you to remember, heliocentric. Remember, the first one was geocentric, and that was the Earth being still in the middle of everything going around it. Heliocentric is more of the Earth being part of the bigger picture. It's moving around the sun. Geocentric and heliocentric. Remember those two words.
Copernicus didn't want to undermine the Church's position, so he waited until the end of his life to share his theories. As expected, they met with a lot of controversy. On a gut level, it was difficult to accept. If the Earth was spinning, how come a rock tossed into the air didn't land somewhere else? And if it was moving around the sun, why couldn't we feel its speed? Clerics pointed out that the new system couldn't make accurate predictions without lots of complex math. But more importantly, it contradicted the Church and the wisdom of the Greeks. Humans were supposed to be the main characters in the unfolding story of our universe. If Copernicus was right, we were just spectators. This radical shift is now known as the Copernican Revolution. There weren't any armies or battles. It was a revolution in thought. The wisdom of the past faced off against open-minded explorations of the world. Direct observation competed with faith in trying to explain the unknown. Over time, people had to accept what they could see with their own eyes. The Danish astronomer Tycho Brahe discovered a comet traveling on a path that would have shattered most of the celestial spheres. One of his students, Johannes Kepler, showed that planets move in ellipses, not circles. That solved the math problems that had plagued Copernicus's model. Finally, Galileo observed moons orbiting Jupiter. Since everything was supposed to orbit the Earth, that was the end of geocentrism. As for the prime mover, Isaac Newton showed that the force of gravity was sufficient to move the stars and planets. He also explained why it seems like the Earth is completely still. When motion is constant and steady, you don't feel it, just like in an airplane or a car on the highway. Now, if the Earth changed speed or direction, we definitely feel that. Do not stop the planet. Thank you very much.
I am so glad that Moby didn't stop the planet. That would have been horrible. All right, guys, so that explains why when I throw my ball in the air, I can catch it. It doesn't come down somewhere else because movement is constant and steady. Right now, all of us on the planet, we're moving at the same speed constantly. It's not going faster or slower or stopping or speeding up, right? It's constant and steady. Everything on the planet is constant and steady. So I'm constant and steady, and my ball is constant and steady. So when I throw the ball in the air, it comes down in the same place. Now, if the Earth were to stop, or the Earth were to go faster or slower or shift or move, we would absolutely feel that part. So thanks to the amazing scientist Copernicus, we learned that our solar system is heliocentric. Remember that word? Heliocentric. It means that the sun is in the middle and everything's revolving around it. Us, the Earth, we are not the center of the universe. And we also learned that gravity was strong enough to move everything in its sorry, I'm joking. Sorry, guys. That gravity is strong enough to keep everything going in their orbits. Pretty amazing stuff, isn't it? I have a challenge for you guys. So make sure you get your permission from mom and dad. But tonight is supposed to be, oh, no, I lied. I was going to say tonight is the pink moon, but by the time you guys get this, that pink moon will be all over. So never mind, scratch that idea. All right, guys, I want you to make something really cool. You should have the printables in your lesson. You should have one printable that is colored solar system and one printable that's black and white. You only need one copy. You can print it out in color or you can print it out in black and white and color it, either way. But we're gonna make these awesome solar systems. See how cool those are? So super fun. So what you're gonna need to start with is a paper plate. And you can paint it black or color it black, or you can use it white or whatever color your paper plate is. And you're gonna cut it into a snake. You just start right in the middle and you just keep cutting circles around and around and around and around until it becomes a snake. And then you're gonna take your planets, your printouts, and you're gonna cut out each planet. Now, make sure when you cut out the planet that you turn it over and you write its name on the back, because it's really easy to forget which planet is which. Once you have them all cut out and all colored and all labeled, you're going to glue them to your paper plate in the right order. So what do you think would go right here in the middle? I hope you said sun, right? The sun is gonna go right here in the middle. Now, do you guys remember how to remember the order of the planets? I have a little trick to help you remember. Let me bring that up for you. Okay, here it comes. Okay, here's our diagram to help us remember. So we have the sun over here, a great big sun. And then we have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune. Do you remember the trick to remembering what order they went in? My very excellent mother just served us nachos. Remember, so my starts with an M, my. Mercury starts with an M. My very starts with a V, and Venus starts with a V. My very excellent mother just served us nachos. And then you can remember the order of the planets. So then you can put your planet on your solar system. Just glue them right on there in the right order. And this looks really cool hanging from the ceiling. And then I want you to go up to your mom or your dad or your brother and your sister, and I want you to take a ball and I want you to say, the earth is moving, right? I want you to trick them. How come when I throw my ball in the air, it comes down in the same place? If the earth is moving, why did my ball not come down in a different place? And when you've got them totally confused, you say, because motion is constant. And when it's constant and moving, everything stays the same. All right, you guys did amazing. I'm so very proud of you. I can't wait to see you all again. I hope you have a great day. Bye.